It's time for Maths with Mr. Thomas.
Hey, hey! Here we are with chapter 14, lesson number 2, the chain rule. Now imagine, Zayad, if I gave you something like this, y equals x squared plus 5, all to the power of 8. How would you differentiate that? What would you do? Yeah, you're right, you would multiply out the brackets. The disadvantage of multiplying out the brackets first is it would take you an awfully long time because you'd have x squared plus 5 times x squared plus 5 times x squared plus 5 times x squared plus 5 and so on 8 times. So you'd have to multiply it all out and that would take you forever. So there is another way of doing it. There's a quick way and that is known as the chain rule. So the steps for the chain rule. How does the chain rule work? Well, that allows you to differentiate something like this. And to do that, what do you do? First of all, you differentiate outside the brackets. So you just imagine that as something to the power of 8. And obviously, if you differentiate something to the power of 8, you bring the power down, you take 1 off the power. So you would differentiate outside the brackets, leaving whatever is inside alone. After that, you differentiate what is inside the brackets. So here, looking inside the brackets, we have x squared plus 5. So you would differentiate whatever is inside. So first of all, differentiate outside, after that differentiate inside, and then after that with both answers, you would multiply them together. So take both parts and multiply them. For example, if you were asked to differentiate y equals 3x plus 4 squared, well, the way you would do that, the way you know to do that, is to multiply out the brackets first of all. So the way we have been doing that, you'd have your 3x plus 4 times 3x plus 4, multiply out the brackets, and you get 9x squared plus 24x plus 16. And then you can differentiate that to give you 18x plus 24. However, that doesn't work too well if this number is bigger than 2, because it would take you too long to multiply out the brackets. So we would use the chain rule. Using the chain rule for this basic example, just to check that we get the same answer, well, here you would say dy by dx, we're jumping straight into differentiation, and you would differentiate outside the brackets. So if you have something squared, well, you'd bring the power down, so you'd have 2 times that something, and you know the something is the 3x plus 4, and you would take 1 off the power, so it would go to the power of 1. What you then do is you differentiate what is inside the brackets. So inside the brackets, we have 3x plus 4. Olivia, that would give you 3. Good. So you would just have 3. And what you do is you multiply both parts together. So we have the 2 bracket, 3x plus 4 to the power of 1, times 3. And that will give us 6 bracket 3x plus 4. And from there, if you multiply out the brackets, really you should leave it factorised, but to show that you get the same answer, well, we get the 18x plus 24. I'm going to do a few more examples then using the chain rule, but let's increase power then, because if it was just to the power of 2, you could easily multiply out the brackets and differentiate it that way. So let's say we had something like this. Example 1, differentiate f of x equals 2x minus 4, all to the power of 7. So we're just jumping straight into differentiation. So we have f dash x. Remember, differentiate outside the brackets. So we've got something to the power of 7. If you differentiate that, you bring the power down, you take 1 off the power. So it will go to 7, and then leave the brackets just as they are, and take 1 off, and that goes to the power of 6. Differentiate inside the brackets. So if you differentiate 2x take away 4, that gives you, well then, so you'd multiply both parts together. So you're multiplying that by 2. From there then, you've got the 7 times the 2x take away 4 to the power of 6. We're multiplying it by 2, so just do the 2 times 7, and our answer will be 14 bracket 2x take away 4, all to the power of 6. Don't start multiplying it out after that, just leave it factorised. Let's try another one. Example 2. Differentiate y equals 2x squared plus 5x plus 6, all to the power of 3. So for this one, again, we're just jumping straight into differentiation. We don't have any roots, we don't have x in the bottom of our fraction, so we can just jump into using the chain rule. Here we've got something to the power of 3. This bit here is in brackets. Remember, you could multiply out the brackets first, but that would take a long time. So the other way is the chain rule. Bring the power down, so it would become 3 times the brackets, and that would then go to the power of 2, because you bring the power down and then take 1 off the power. Differentiate what's inside the brackets. So inside the brackets here, 2x squared plus 5x plus 6. If you differentiate that, that will give you 4x plus 5, and you multiply both parts together. Just make sure you put brackets around what you get when you differentiate this inside part, because you're multiplying everything by that. From there, well, again, you could multiply out the brackets. That would take you a long time. You're best leaving your answers factorized, especially in preparation for next year. But that would be the 3. I'm putting the 4x plus 5 first, and then I'm doing this, putting the highest power at last. So your answer will just be 3 bracket 4x plus 5, close bracket, open bracket, 2x squared plus 5x plus 6, and then you've got that squared. Example 3, differentiate h of x equals 2x take away 9, in brackets, to the power of negative 2. Woo. So how would you do this one? Exactly, yeah, you use the same method. So again, you're just wanting to jump into the chain rule. So h dash x would equal, bring the power down, so you'd have negative 2 times the brackets, and that would go to the power of negative 3, perfect. And you would then multiply that by the derivative of what is inside the brackets. Differentiate 2x take away 9, and that will give you 2. So you'd multiply all of that by 2. From there then, we've got negative 2 times 2, so you could put them together, so you've got negative 4 bracket, 2x take away 9 to the power of negative 3. And from there, you could leave it as that, but remember you're best writing it with a positive indices. Sometimes you're asked for that, so you could just move the bit in the brackets with negative 3 to the bottom of your fraction, leave the negative 4 where it is, so you'd have negative 4 over 2x take away 9, and when you move it from the top to the bottom, the index will change from negative 3 to positive 3. So that is your answer with a positive index. Example 4, differentiate f of x equals 3 minus x to the power of 1/3. So for this one, again, we don't have any root signs, we don't have x in the bottom of a fraction, so we can just jump into differentiating. So here, differentiate that, you would end up with f dash x, and you're using the same method. Differentiate outside the brackets, so something to the power of 1/3, bring the power down, so we'd have the third at the front. Keep the brackets as they are, so keep x take away 3 take away x, and take 1 off the power. So 1/3 take away 1, remember the quick way of doing that, do top take away bottom, so 1 take away 3 is negative 2, and keep the thirds as they are, so it's negative 2/3. After that, differentiate what is inside the brackets. If you differentiate 3 take away x, you will end up with negative 1. Perfect. Don't miss out the negative. Okay, you've got 3 take away 1x, so if you differentiate that, you would get negative 1. And here, I'm using a dot rather than a time sign, but the dot just means times. You're timesing them together. From there then, you've got a third, you're multiplying that by negative 1, so that's just really going to be negative 1/3. You've got this 3 take away x to the power of negative 2/3. Remember, you may be asked to write it with a positive index, so keeping the negative 1/3 as a fraction, negative 1/3, and then moving that 3 take away x from the top down to the bottom of the fraction, so that would go to the power of 2/3, and that would be your answer. Example 5, differentiate f of x equals 2 over the square root of t squared take away 3t take away 1. So the first thing you would have to do with that, help us out. What would you do, Grace? Perfect, you would have to rewrite that. Here we've got a root sign and we've got t on the bottom of the fraction. So we need to rewrite it. The square root, Grace, means to the power of half. Good, and we'd then move that up to the top. So we've got 2 times the t squared take away 3t take away 1 to the power of negative 1/2. Once we've done that, we can then differentiate. So we'd have f dash t. Remember, we've got the brackets to the power of something. Leave the brackets just as they are and differentiate outside first of all. So bring the negative 1/2 down and multiply that by 2. So 2 times the negative 1/2. Leave the brackets just as they are, so we've still got t squared take away 3t take away 1. And from there, take 1 off that power. So the negative 1/2. Negative 1 take away 2 is negative 3, so it's negative 3 over 2. From there, we have to then multiply by the derivative of what is inside the brackets. So if you differentiate what is inside the brackets here, well, you've got the t squared take away 3t take away 1. Differentiate that and you get 2t take away 3. So we're multiplying by the 2t take away 3. From there, well, you could rewrite that. You're thinking the 2 times the negative 1/2. Well, 2 times 1/2 is just 1. We've got that negative 1. We've still got the t squared take away 3t take away 1 to the power of negative 3 over 2, and we've still got the 2t take away 3. From there, you're best rewriting this part with a positive index, so the t squared take 3t take 1 to the power of negative 3 over 2, move that to the bottom of the fraction, so that would become to the power of 3 over 2, and if you multiply the 2t take away 3 with the negative, you could just leave it as negative bracket 2t take away 3, or you could multiply it out, and that would give you a negative 2t and a positive 3. Rewrite it with a positive first of all, so I've got 3 take away 2t. And as I said, this part here with the t squared would go to the bottom, and the index would change from a negative to a positive. Example 6, find the rate of change of f of x equals 5 bracket 3x take away 4, all to the power of 4, when x equals 2. For this then, how would you go about doing it? What are you thinking, Madiha? Excellent, well done. Rate of change just means differentiate, so we want to differentiate f of x. To do that then, again, you're going to have to be using the chain rule. So let's differentiate outside the brackets. So we're bringing the 4 down, and we're taking 1 off. So it's 5 times the 4 times the 3x take away 4 to the power of 3. And then we're going to be multiplying that by the derivative of what is inside the brackets. In the brackets here, 3x take away 4 differentiates to become 3. So we multiply by the 3. Simplify that, 4 times the 5 times the 3 will give us 60, so it becomes 60, bracket 3x take away 4 to the power of 3. After that, that is going to be the rate of change, but we're wanting it when x equals 2. So you would then replace x with 2. So instead of f dash x, we've got f dash 2. And that would equal 60 times 3 times, instead of 3 times x, we've got 3 times 2, take away 4, all cubed. From there then, that would give us 60 times 2 cubed, which is going to be 60 times 8, which is going to be 480. And that would be your answer. Woohoo! Let's try another one. Example 7, find the stationary point for the function f of x equals 8x minus 2x. Take away 1, and you've got the 2x take away 1 to the power of 4 over 3. So to get the stationary point, how would you go about doing that? Excellent. You would differentiate. So first of all, f dash x would equal 8x differentiates to become 8, and we're going to be having take away. Bring the power down, so you've got the 4 over 3, keep the brackets as they are, so 2x take away 1, but then take 1 off the power. So 4 thirds take away 1 would become 4 take away 3 is 1, so it becomes 1/3. And we're going to multiply that by the derivative of what is inside the brackets. So differentiate inside the brackets. 2x take away 1 differentiates to become 2, so we're multiplying by the 2. After that, tidy that up slightly. We've got the 4 thirds, we're multiplying that by 2, so that's really 2 over 1, so 2 times the 4 gives us 8, 1 times the 3 is 3, so it's really 8 take away 8 thirds, and we've still got the 2x take away 1 to the power of 1/3. We've differentiated that, but now we want to get the stationary point. What is that phrase that you have to remember? Sandy, help us out. Yes, well done. Stationary points occur when dy by dx equals 0, or in this case, because it's f of x, they occur when f dash x equals 0. So that's the derivative, that is f dash x. Let's set that equal to 0. From there then, if we add the 8 thirds, 2x take away 1 to the power of 1/3 to both sides, then really we would have that equal to 8. Multiply both sides by 3 to get rid of this fraction, and we'd have 8 bracket 2x take away 1 to the power of 1/3 equals 24. That's just multiplying both sides by 3. From there, divide both sides by 8, and the 2x take away 1 to the power of 1/3 would equal 3. To the power of 1/3 means the cube root. What's the opposite of cube rooting something, Matthew? Cubing it. Yes, so cube both sides. If you cube the power of 1/3, well, that just undoes the cube root, but then you cube the 3 as well, so you're left with 2x take away 1 equals 27. From there, add 1 to both sides, divide both sides by 2, and x would equal 14. What you need to remember though, we are asked to find the stationary points. We have to prove it is a stationary point, so we need the nature table. You always have to include that if you're asked for the stationary points. So you take your value of x, that was 14, and you sub in a value just before and after 14. into f dash x. If you sub 13 into f dash x, if you put 13 in here, so 2 times 13, take away 1, do that to the power of a third, multiply by the 8 over 3, and then 8 take away that, well, you end up with a positive number. Because it's a positive number, it means the gradient is positive, so the graph is sloping up the way towards that 14. If you sub 14 in here, well, you will end up with 0. Just double check that to make sure you have not made a mistake. But if it is 0, the gradient's 0, so it's just flat at the top there, or the bottom. And if you take the number just after 14, say 15, if you sub that in, 2 times 15, take away 1 to the power of a third, multiply by 8, divide by 3, 8 take away all of that, will give you a negative number. And when it's a negative number, it means the gradient is negative, so the graph will be sloping down. So here you can see the graph is sloping up, then suddenly it's flat, and then it's sloping down again. So your graph will be looking something like that, meaning then that that point will be a maximum turning point. To find the stationary point though, well, we know there's a stationary point when x is 14, but we're asked for the actual point, so we want the coordinates, we want the x and the y. How would you go about finding out what y is equal to? Perfect, you sub that into the original equation. So we replace x with 14 to find out what y would be, or f of x, find out what that would be. So f of 14 would become 8 times 14 take away, and then in brackets we'd have 2 times 14 take away 1 to the power of 4/3. Work that out. You could just use a calculator for that, but you get 112 take away 27 to the power of 4/3. Remember, to the power of 4/3, at the bottom you've got the root, so it's the cube root of 27. Multiply that to the power of 4. From there, that gives us 112. Take away 3 to the power of 4, which is 112 take away 81, which is 31. Therefore, you know the y-coordinate will be 31, the x-coordinate is 14, so you can say that there is a maximum stationary point, or a maximum turning point, at 14, 31. And that will be your answer. Let's try one more. Example 8. Find the equation of the tangent to the graph of y equals 2 over 4x take away 1 at the point where x equals 1. Think about this. We're wanting the equation of a tangent. A tangent is a straight line, so we want the equation of the straight line. Whenever you want the equation of a straight line, you should be thinking gradient point equation. Gradient point equation. So, to get the gradient of the graph at the point where x equals 1, how would you go about getting that? What would you have to do first of all? Excellent. You would differentiate. Now, to differentiate this, we have x in the bottom of a fraction, so we'd have to rewrite that. To rewrite it, how would we go about doing it? Help us out, man. Excellent. We can move the 4x take away 1 from the bottom of the fraction up to the top. So put brackets around that, and it would become 2 times the 4x take away 1 to the power of, well, if you put brackets around that, it's to the power of 1. If you move it up to the top line, it would be to the power of negative 1. Well done, man. From there, differentiating then, well, just use the chain rule, as we have done in the other examples. So dy by dx would equal, bring the power down, so 2 times the negative 1. Keep the brackets just as they are, so we're keeping the 4x take away 1, but that would go to the power of, take 1 off, so go to the power of negative 2. After that, differentiate inside the brackets. So inside the brackets, we have 4x take away 1, differentiate that, and we get 4, so we'd be multiplying that by 4. Tidy that up slightly, and that would become negative 8 over the 4x take away 1 squared. So the 2 times the negative 1 times the 4 will give us negative 8, and we're moving the 4x take away 1 to the negative 2 just to the bottom of the fraction, so that goes to the power of 2. After that, well, we have to find the gradient, but we've just got dy by dx equals negative 8 over 4x take away 1 squared, but we know the value of x, so we can say when x equals 1, dy by dx, which is really your gradient, will be negative 8 over 4 times 1 take away 1, all squared, which becomes negative 8 over 3 squared, which is negative 8 over 9. So that will be the gradient of that tangent. The point, well, we know x is going to be 1. We're needing an x and a y coordinate, though. How do we get the y coordinate? What would you do with that? Excellent. You can sub x equals 1 into y, and you can find out what y would be equal to. If you do that, if you sub it into y equals, you will end up with 2 over 4 times 1 take away 1, which gives us 2 over 3. You know then the point of contact for that curve and the tangent at that point is going to be 1 and then 2/3. Gradient point equation, so we've got the gradient, we know the point. After that, we're wanting the equation y minus b equals m bracket x minus a, sub in a, b and m. So it's going to be y take away 2/3 equals m, which is negative 8 over 9, bracket x take away a, which is 1. If you multiply every single term by 9, well, you're multiplying the y by 9, so that gives you 9y. Multiply the 2/3 by 9, so 2 times 9 is 18, divide by 3 gives us negative 6. And multiplying this side here by 9 will just give us negative 8, bracket x take away 1. From there, multiply out the brackets, moving the 6 over to the other side, or adding 6 to both sides, just putting the numbers together. So I have an 8 add 6, which will give me 14, and I'm adding x to the other side as well. So I've got 8x add 9y equals 14. Remember, there are different ways that you can write that. You could have it in the form of y equals, you could have everything to one side, so it equals 0. It doesn't matter how you write it, as long as you've gathered together all your x's, your y's, and the numbers. Woo! The chain rule. Give these questions a shot. See how it goes. It's TJ Higher, page 225, exercise 3A and 3B. Good luck. Let me know how it goes.